Alright, there's a lot of theorems in this section, so pay attention. They're very simple, so I'm just going to kind of point out the important pieces of this. You can use your note-taking guide if you want, and I hope I can kind of go through it real quickly here in a minute, part of it. But I just want to point out some things. These first, if I get an 8.5, Midsegment of a trapezoid, and kites. That's what we're talking about. The first three that you come up with here, 8.14, 8.15, and 8.16, these all have to do with isosceles trapezoids. What makes isosceles trapezoids? And if you're sitting there thinking, well, isosceles, that means triangle. No, the definition of isosceles means you have at least two congruent sides. It doesn't have to deal with triangles. So in an isosceles trapezoid, you have two of the sides that are congruent to each other, which is why those are marked. What makes a trapezoid is that you only have one pair of sides that are parallel to each other. You have to have the parallel sides. The other two sides do not have to be parallel. Alright? So the first one, if a trapezoid is isosceles, again these first three are about isosceles, then each pair of base angles is congruent. So the top pair, so that your parallel lines are your bases. So this is base 1, base 2. So the top base angles are congruent to each other, and the bottom base angles are congruent to each other. That's what the first theorem is stating. And then theorem 8.15, if a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So if you didn't know that A, B, and C, D were congruent, but you knew the base angles were congruent, you then could say that those lengths are the same. That's what that theorem is stating. And then theorem 8.16, the trapezoid is isosceles. It is isosceles if and only if your diagonals are congruent. Okay. Notice they don't look like they intersect at 90 degrees. They're not perpendicular. I think that's pretty obvious, but there may be some trapezoids you're not sure of. Just remember they're not perpendicular to each other. But they are congruent. So AC is congruent to BD. Three theorems telling you different things. One about base angles. Another about if you have base angles, then your opposite sides are congruent. And then about your diagonals. You need to make sure you know the difference. That's just the first three of this section. Don't forget the ones you learned yesterday. Okay? You have a quiz on Friday, 8.4 to 8.5, 8.4, 8.5, and 8.6. And tomorrow we get more. So you need to make sure you're on top of which ones these are. Alright, having said that, let's look at the other ones and then we'll do some examples. Midsegment theorem is pretty simple. All it says is this, that first of all, the midsegment, where is it? It's halfway in between your parallel lines. That's where the midsegment is. It's not this midsegment. It's not a vertical line. Okay, it's a horizontal line between your parallel lines, halfway in between. Now, the distance of the midsegment, the length of it, is half of the bases added together. So you add the top and the bottom bases together, divided by 2, and that gives you the length of your midsegment. That's what that theorem is stating. Half of the base 1 plus base 2. Anybody know the formula for area of a trapezoid? Half of the bases added together times the height. So the midsegment theorem is very close to the area of a trapezoid. All right, let's take a look at the other two. Now listen to me. This is a kite, two kite theorems. This is very important. Okay, we don't always talk about kites, but they're special. So if it is a kite, so you're being told it's a kite, then you know that the diagonals are perpendicular. If it says it's a kite, by this theorem, theorem 18, you can say that the diagonals are perpendicular to each other. If it doesn't say it's a kite, you can't say that. The second one, if it says it's a kite, then these are the only two angles that are congruent. if it's a kite, it's kind of oblong, okay? It's not a parallelogram, it's not a rhombus. So angle B and angle D are not congruent at all. But if it says it's a kite, you know you got perpendicular diagonals, and the opposite angles are congruent. Just that set. Okay, and then you also know about the outside. These two short legs are congruent, and the two long legs are congruent as well. That's what makes the kite. Those specific things. Alright, so we kind of went through that really quickly. Let's look at some of the examples. I'm going to pull out the note-taking guide to look at some of the examples. Just, you guys, make sure you have that out in front of you. I've already done part of it, but I'll pull out a few things here. Alright. So, in example 1 here, this is not example 1. In example 1, B, this is C here, B, C, and F was labeled, if you have your note-taking guide out, you can look at it, and E was in a different position. It's now saying if we put E in this position, what shape does this make? That's all it was asking. What is that? It's not a square. Not a rhombus. This is longer than this one. It's a parallelogram. That's all. So, don't get too crazy about it. And then down here, angle C and the measure of angle A and the measure of angle D. I've already wrote them in here, but I want to show you what, if you're given one angle and it's an isosceles trapezoid, you ought to be able to come up with the rest of them. Why is that? What was the one of the first theorems? Base angles?
The base angles are congruent.
Base angles are congruent. So this base angle is congruent to that base angle. So that had to be 135. How do I know that these are 45 each? They're not supplementary. Are they? Yeah. Yeah, there's 360 degrees in them, right? So you subtract whatever's left from this from 360 divided by 2, and you get those two. Those are supplementary. Well, I'm not saying they're all supplementary. Might want to check that out. Okay? Alright, so those are the first two examples of application. Let's take a look at this. I didn't do these because I wanted you guys to answer them as well. What is the length of MN? Tell me how you figured it out. The length of MN. The midsegment. What did we say it was? Remember, it was almost like the area formula of the trapezoid?
16 plus 9 divided by 2.
Yeah, 16 plus 9 is 25. 25 divided by 2 is 12 and a half. Good. Alright. Somebody else tell me the answer to that one. What is MN? What is the length of that midsegment? 21. 30 plus 12 is 42. Divided by 2 is 21 feet. Good job. And let's take a look at the kite problem here. Number 4. The measure of angle G in the kite shown at the right. How do I know what the measure of angle G is? How do you figure it out? Gracie?
You take 180 and subtract 75 and 85, and then divide the remainder by 2.
How about 360?
Or 360?
Yeah.
180.
Yeah. 360 degrees is the total interior. Subtract these two from it. These two are the same. G and I are the same. So divide that answer by 2 and you got your answer. Okay? Any questions? Being able to prove that G and I are the same, that's probably a good thing to try to come up with. Alright? I'll try to give you something on your homework assignment. Your homework assignment is right there. We can get started on it. I can answer some questions.